whose resultant is 0 can be repeated by drawing them end to end, so that they form a closed polygon. This is called a polygon of forces. If the polygon is not closed, there is a non-zero resultant force. For our experimental theory, in the design of pin-jointed plane structures such as girders, bridges, and roof trusses, it is necessary to find the forces acting in each member so that the frame can be made strong enough to withstand the maximum loads exerted upon it. The polygon of forces is frequently employed to find such forces and deals with each joint in turn. This experiment could be regarded as one such joint on the structure, and it will be shown that in the system containing 4 or more forces, 2 unknowns can be found in magnitude or direction if the remaining information is known. The polygon forces is an extension of the triangle of forces, and whereas tri means 3, poly means many. So for our experimental equipment is 1 diagram board and clips, 4 pulleys, 5 weight hook, 1 set of weight, and then 1 ring with 5 cords attached, and some sheet of plain paper.
My name is Amiro bin Fazil. My metric number is AD170126. I'm from Group 7. Now I want to explain the procedure for the polygon of forces. First thing, we need to secure the mounting panel as we already do it. Okay, next, clip a sheet of paper to the board and assemble with cords and weight. Okay, the next step is add weights to give total weights. Okay, for the fifth cord, we only use it when we do for the test B. Gently cause the system to bounce by jogging the cord. Okay, and mark the position of the cord. After marking the cords, remove the paper, join up the dots representing the cords. For the test B, we keep the weight from the test A, and we add a new weight to the fifth cord here. The weight is 1.1 Newton, including the hook. The sheet of paper to the clipboard. And then we bounce the system of jogging the center of weight only. Okay. Then mark the position of the 5 cords. Okay, remove the paper and join up the dots.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Adam bin Ismail. My metric number is AD170144. I'm from Group 7. I will present to you the result of the experiment of polygon of forces. So for the test A, on the diagram sheet, we need to mark the space between the chord line A, B, C and D. Then we need to draw a force diagram by first drawing scale length of AB and BC to represent the force W1, this one, and W2. Then through C and A, draw line parallel to the direction of W3 and W4 based on the direction of W3 and W4 to meet at D, covering the whole circuit. The figure ABCD is the force diagram for polygon of forces for the four forces W1, W2, W3 and W4. Then measure the length of CD and DA. So what we have obtained from the experiment is the length of CD is 12.3 cm and the length of DA is 13 cm. For the test B, firstly, based on the space diagram, draw the space diagram, which is this is one, this is A, B, C, D and E. Then draw a separate force diagram using the scale line of AB, BC and CD to represent the force W1, W2 and W3. Complete the diagram by drawing line parallel to the direction of W4 and W5. The figure ABCDE is the force diagram or polygon of forces for the 5 weight W1, W2, W3 and W4. Then measure the length of DE and EA. So what we have obtained for the experiment is the length of DE is 12.4 cm and the length of EA is 11.3 cm. For the observation of the experiment, for test A, what we can observe is when we pull the fifth cord, what we can see is the weight 2 and 3 is moving upward and the weight 1 and 4 is moving downward. Also, same goes for the test B. When we pull the fifth cord gently, what we can see is weight 2 and 3 is moving upward and weight 1 and 4 is moving downward. So the difference between test A and test B is the position of the center of the cord, which is for test 1 is a bit higher than the test B. This is for the test B. It's a bit lower than test 1.
Discussion. Length of CD from the experiment, weight 3, test A that we get is 7 Newton. Length of DA, weight 4 from the experiment, test A is 5.3 Newton. Length of DE that we get from experiment, weight 4, test B is 3.7 Newton. Length of EA, weight 5, test B is 7.8 Newton. They are slightly different in value between the calculated weight and actual weight. For the test A, actual weight 3 is 2.1 Newton, whereas the calculated weight is 7 Newton. Besides, the actual weight of weight 4 is 1.6 Newton, whereas the calculated weight of weight 4 is 5.3 Newton. For the test B, the actual weight 4 is 16 Newton, whereas the calculated weight is 3.7 Newton. Besides, the actual weight of weight 5 that we get from experiment is 1.1 Newton, whereas the calculated weight 5 is 7.8 Newton. The presence of difference in actual weight and calculated weight due to both error of random error and systematic error. For the random, it may be happen due to the parallel error, and another one is systematic error.
Hi, greetings. Okay, first I'm going to introduce my name. My name is Mercedes Shafri Jr. My metric number is CD107117. Okay, I'm from group 7 and I'm going to conclude this experiment for polygon of forces. Okay. From this experiment, we can learn that the method of using polygon or forces when there are two or more forces acting on a point like this, like as you can see here, five forces is acting on a single point. Alright. The set of forces can be represented in drawing by linking them with end-to-end form. As you can see, this we use this sheet of paper to determine the direction of the forces here. Link-to-link form is where you draw a polygon like this. Okay, this is what you call a link-to-link form or end-to-end form. Alright. This is a closed polygon, means every side is closed. With this, we know with this the system will be in equilibrium with zero resultant force. Then up to two unknowns of forces in magnitude or direction can be determined from the closed polygon using the remaining information that is known. Next, by comparing the calculated weights and the actual weights, there is a slight deviation between them. This may be due to a certain systematic error, such as friction in the pulley, random error or parallax error while jotting down the position of the chords. Alright. During this experiment, we have encountered a few problems. Okay, one of the problems is weights of the hook touch the base because the chords is too long. As you can see here, this is the chord. Before this, the chords were too long, so this number 5 weights was touching the base. Okay. Next is the marking of the chord in paper sheets was not accurate because we were not careful. While we were marking on the paper, there were a slight deviation in the marking lah. So next, our problem was the problem is a friction of the pulley. Since as you can see, the pulley is quite old, so maybe the free moving pulley is not smooth anymore. So there's a possibility of friction messing with the experiment. So with all these problems, we already come out with the steps to overcome it. One of the steps to overcome the chords problem is we made a new chord which is appropriate to the length of this diagram. Next is to avoid parallax error, while marking the chords in the paper, we make sure to place our eye directly on the chord to avoid parallax error. And the next one is to decrease the chances of friction in the pulley, we put a slight lubricant on the pulley and also the bearing inside. So that's the conclusion for our experiment in polygon of forces. Thank you.